All right, timer is set. Hello, hello. What up, class and everybody? Okay, well, I just wanted to do a quick review, trying to help class move a little bit smoother, you know. So, last video we talked about what? Standard notation, right? So make sure you have your vocabulary cards. Hopefully you're making flashcards. Vocabulary is very, very, very important in math because, as you know, especially if you've already watched a few of my older videos, whatever we say, when we say it, that kind of tells you what to do. So you have to read the question, right? Read and see what the question's asking you for. And I always use the example, like if we say systems of equation, I instantly think substitution, instantly think elimination, and if you've done up to college algebra board, you know the matrices is included in that, right? That's also a method for solving a system of equations. So, real quick, we had standard notation, what is it? Expanded notation. And we had word names. There it is. No, it was one more. Right? And so what do we call digits when they're in a large, or when they're in a number? When we put the digits together, they make up a number. I guess I already told you. If you say you had, give me a good number. Let's say 4974, right? So we know we have this period right here. Ones, tens, hundreds, thousand, 10,000s, right? So in standard notation, we have what? 49,745. Do not say and, because there is no decimal. You only say and if you see a decimal. That would be 49,745 and 23 hundredths. Tenths, hundredths. Okay? 49,745 and 23 hundredths. Standard notation. Now, expanded notation, remember, that's going to cause for a little bit more writing. So let's try to write this in expanded notation. Expanded is going to be, we have, what do we say? 4 in the what? 10,000s. Is that right? Ones, tens, hundreds, thousands, 10,000s. 4 10,000s plus what? 9,000s. Plus 7 hundreds. Plus 4 tens. Plus 5 ones. And I'm just going to write this just for the video's sake. 23 Oh, I can't believe I said hundred with a D. Hundreds. Right? This is called expanded notation. Because we've expanded, we've showed what we've added together to get what digits we've added together to get this cumulative amount, this big whole total, right? Standard notation is written like this. Expanded notation is written like this. And word names. Here we go with the word names. Word name is, so we're going to say 40 There's no Y in 40. I mean, no, U. F-O-R. There we go. 49,000. 700. 45, right? 49,745. And I put that in capped and underlined so you remember 23 hundredths. TH, hundredths, right? So here, let me help you out. This one is word names. Let's see, expanded notation. I'll leave the blues even though the blues don't match. And then standard notation. What did we write that color in? All right, standard notation goes here. Wait, I think my arrow will be better here because then, don't talk about my arrow. Don't talk about it. And then we can show word names goes here. And then we can show that standard notation goes here. I know I didn't want to cross colors. That's the OCD, don't worry about it. But okay, all right, make sure that's in your notes. Make flashcards if you need to, whatever you need to do to help yourself be successful in this course because we said that we had some hard work to do, right? So get after it, it's not gonna be easy. The next thing we're gonna talk about, and again, a lot of this could be just review for a lot of you, and that's cool, but you probably need to know the proper terminology again. It's gonna help you understand what the expectations are as you progress through your math, right? Because sometimes you miss the question because you answer too much, right? Okay, so you got that? Cool, it's coming down now. Pause it if you need it. So now we're going to do addition. And addition is just what it says. We're putting things together, right? We're accumulating, we're totaling, we're gathering it all together, we're putting it all in one spot. The rule with addition of whole numbers, as you can see, math is based off of tens, right? After every 10, you start over. What does that mean? Well, that means you count from 1 to 9 and then you get to 10. And then if you pay attention, you get 11, 12, right? All the way up to 20. And then you start over again, right? You start over with the 1. So what I want you to recognize, you do this all the way up to 30 and so forth. So you're counting by tens, because even before you got here, there's that 1 again, there's that 2 again, and it's going to go all the way up. So this would be that 9 again, and then 20. There's that 1 again, there's that 2 again, there's that 3 again, but each time you're adding some tens, right? First you started with no tens, and you got up to 10. 10 more gave you 20. 10 more gave you 30. So the whole number system is based off of 10. All right? That's a whole research paper I had to do years ago. Can I remember all the reasoning? No. But if we want to find out, we can. We can look that up together later. For right now, we're just going to talk about addition and what we're doing because we want to talk about addition of whole numbers. So like I said, you probably remember all this, but here's a little bit of backstory on it and what's going on and why you have to do things like carry and stuff like that because we're going by tens. So we always line our numbers up, right? So when we're adding, so if you are adding values such as, let me pick something good. Because you know I can't be making examples. I can, but say we're adding something like 563 plus 48. Right? Well, we remembered, and so remember math carries over. Rules don't ever change. And so math is based off the premise that as you advance to the next concept, you're still applying what you prove. You're bringing with you what you learned before. So you already learned before that this is ones and this is tens. Same thing here, this is ones, this is tens, this is hundreds. So when we're adding and subtracting, because those are inverse operations of each other, it's like opening and closing the door, tying your shoe, untying your shoe. I know you'll hear me say it a ton of times because it's true and it doesn't change. When we are adding and subtracting, we must line up our digits. We must line up our periods, however you want to remember it. We have to line up our values to do so. So we line it up. We know this is the 5, the hundreds, the tens, the ones. So we'll put the tens and the ones together. We're adding. So again, each 10 it carries over, right? Because we can only represent values of 10. We can only represent 1 through, we can only do these in single digits. Okay? Once you get to 10, there's 2 digits. And so that's why we have to carry, because we can't, I don't know how to explain it. You can't have 2 digits. Like if you have $34, you wouldn't say, we don't say we have 3 tens and 4 ones. Even though that's how you do it in your expanded form, that's how it comes about. That's not how we vocalize and that's how we express for convenience. So just know that because we're lazy people, we stopped talking like that. But we did used to talk like that before. In this case, 8 and 3 more makes 11. So 11 is 1 more than 10. Correct? So we're going to write that 1. And then we're going to carry that 10. But it's not that 10. We'll just carry the 1. You're carrying it over. It's like you have to borrow the 10. You'll see. I'll find better words to explain that over here. But you're carrying that extra 1 over because it's 11. So you wrote the 1, and then that 1 gets carried over. 6 and 4 is also 10. Plus 1 makes 11. And you carry that 1 over again. 5 and 1 makes 6. So everything is still lined up. You can always check this because you have a calculator, but I don't advise you pushing buttons. Right now, I know you will just to check your calculations, but trust in me and in yourself, in your skills and knowledge, okay? Relying on that calculator kind of makes you question everything now. You should not be on the calculator to go 8 plus 3, right? Use your fingers and toes. That's what they're there for. Literally, for real. Part of all of that is to help you utilize it and be successful and know what you're working with. Told you math is a natural function. How did we add? We used our fingers and toes. So 8 plus 3 more, 9, 10, 11, right? 6 plus 4 more, you start with 6, 7, 8, 9, 10, right? You got this. We add them up, we keep everything in the row. It doesn't matter how many values, numbers that we have, no matter how many digits, rules do not change. If that is what you will do, you will always line it up. So let's just take one of these little examples we have here. Let's see. I don't see anything good. Okay, let's see what I got. Let's come up with something, right? I want to give you something challenging. And then we'll do, right? We are adding all these values. Again, we're dumping this together. Maybe we had 394,986 marbles. And we put all of those in the bag. And then we probably had 1,952 jacks. We put all those in a separate bag. Then we had 17,038 pebbles. We put those in a separate bag. We just separated them all. And then someone said, so how much do you have all together? Then we would have to add those digits, correct? So 8 plus 2 is 10. 9, 10. Plus 6, 16. Right? We carry that one. I see 8 right here, and I see 8 right here. I know 8 and 8 is 16, plus 1 makes 17. So if I'm adding too fast, take your time. But know that I'm following the same rule I told you. I'm just putting it all together. And because I'm so used to adding quickly like that, that I've gotten a little bit faster at it. So what that means is with repetition, as you do it more, your speed will naturally increase as well. All right, and you'll hear me, and I think I've already said it, how knowledge is stored in the brain, right? Like a little path, and you have to travel that path repeatedly in order for it to be ingrained, okay? Where are we at? 99 is 18 plus 1 makes 19. Carry that one. And I am choosing to add the values I know that are easiest to me, the ones that I'm more familiar with. I know 7 and 1 makes 8, 8 and 1 makes 4, but for me, 7 and 4 make 11 was easier, plus that 1. That made that 12, right? So however you want to add them, typically, until you get good at it, start at the top, add the next value, add the next value. If you have to go up to the side and add these two values, and then add this to that total, that's fine, you all. You're here to learn about the process. So don't let anyone else pick on you about how you learn it, okay? Be strong in that, especially if you're doing it the right way. All right, so I did 7 and 4 is 11, plus 1 is 12, plus 1 is 13. Carry that one. Now, even though there's nothing here, a lot of times in schools they will have you add a 0. Actually, a lot of time in school they have you put the largest number on top. Well, we just skip that part, okay? But yes, it is the same thing. Adding a 0 represents that there is no value there that we're adding, so it's okay. It takes the place. Since our period goes all the way to the 100,000s, this one goes to the 100,000s. This one just goes to the 1,000. This one just goes to the 10,000. They're all in the different periods. So you still will always start with the ones and line them up. And like I said, most places will have you put the larger number first. I believe in keeping the order it was given to you. That way you're not mixing up too much stuff and varying too many things. Right? Okay. We were at 9 and 1 is 10, plus 1 is 11. Now carry that one, 3 and 1, make 4. Final answer, woo, comma got a little big there, right? 413,976. What do you think? Check my math. Check my math. Tell me what you think. I just made these values up. Right? I know I'm pretty right now. Okay? If you have any questions or anything, let me know. Reach out. Don't hesitate. Subtraction is just the exact opposite, like I said. So instead of putting a bunch of things together, we're taking things away piece by piece. Okay? Now with subtraction, you do have to put the largest number up top. This is before we start to work with integers. Okay? And I'll tell you when we get into, remind me of I have an additional word I want you to know. remind me before we get into integers, I will tell you that all numbers are integers. And so right now, I'm going to tell you that we're working with all positive values, okay? Because if there is no sign, then it is positive. And right now, we're working with all positive values. However, you have not, technically, our chapter hasn't introduced us to integers, so you're not aware. Hopefully, though, you are aware and you know what's up, okay? So for right now, though, we're working with all positive values. And then that second part that I remember, I was like, oh yeah, remind me to tell you. An addition word I want you to be very familiar with. Perimeter. Perimeter. Perimeter is the area, let me change my words. I don't want to use area because area is a different representation. Perimeter is the distance around an enclosed space. Let me rephrase a little bit more. The distance around a rectangular or square space. Okay? So let me get this out the way for you a little bit. So when I say the distance around a rectangular or square space, name something rectangular or square. Typically a garden, a pool, the bottom, the frame of a house, if you're building a house, if you're working on a parking lot, like so many things, right? You have tables, you have desks, you have windows, there are doors. There's a plethora of things that are rectangular or square. And so if you talk about this distance here, plus this distance here, plus this distance here, and plus this distance here, if you add all those distances around, you are referring to the perimeter. And that is geometry. Yes, it is shapes and measurements. Rules don't change. And that's what it means. The word perimeter, though, means that you are going to add. Okay? So when you get up in your math and you read the question that says, Pam and Soon are going to build a kenneled in area up against the fence. Check it out. If it's up against the fence, I'm just saying, don't judge my fence. But if it's up against the fence, then it's missing one of the sides, correct? Because it's up against the fence, so then you're only going to add these three sides. Be attentive to your vocabulary. Be attentive to the words in your math, okay? Slow down. It's not as bad as reading the fine print. I guarantee you it's not that bad. You got this. Just got to take a second. And just because it's math, it does not mean something different. Like words mean the same thing. When I was talking about perimeter, let me also say, when I was trying to make my own definition, I chose the word rectangular or square, but it's not limited to that. It can be, you can find the perimeter of any shape pretty much. Although if you're looking for the perimeter of a circle, it has its own name. That's all that is. But you can find the perimeter of any shape of anything. Yes, you can find the perimeter of that, because all you're going to do is take the measurements for each side. Make sure you get every side though, right? But if you add the measurements for each side, that's called the perimeter, okay? So let's just say this was 2, well that's long, let's call that 12. Let's call this 3. Let's call this 19. Let's call that 1, call that 1. We'll call this 6, we'll call that 4, we'll call this 8, we'll call that 2, we'll call these 2. Right? So if we're finding the perimeter of this crazy shape right here, we're simply going to add all of the sides. Plus 1, plus 2, plus 2, plus 2, plus 8, plus 4, plus 6, plus 1. Right? And so I simply just touched each to make sure I got each, and then I will just add it in the order that's given to me. 12 plus 3, 15, 15 plus 19. I might have to come to the side of my paper and add what 15 plus 19 is. 34 plus 1 makes 35, plus 2 makes 37, plus 2 makes 39, plus 2 makes 41, plus 8 makes 49, plus 4 makes 53, plus 6 makes 59, plus 1 equals 60. So all of this is 60. So the perimeter of this shape right? And then whatever the units, 60 inches, 60 feet, 60 yards, whatever it says. Oh, our time's about up, you guys. So again, remember that subtraction. Okay, that's all that for addition. Subtraction does not, perimeter does not mean subtraction. Perimeter does not mean subtraction. It is only an addition word. For subtraction, you're going to do the exact opposite. I'll throw 1 up here before I go. My time is up. That means I have like 2 minutes left on the camera. Let's say we have right? So remember that. Subtraction is the opposite of addition. There's really no real definition for subtraction besides this being the opposite of addition. But you can always check your subtraction with addition. So say you're taking 348, and from that, you're taking 165. You're taking 165 from 348. That's what this says. 348 minus 165. 165. So 348 is losing 165. You're taking 165 away from 348. So 8 minus 5 is 3. Now you can't take 6 away from 4. Because 4 is only this many. You don't have enough to take 6 away from it. So you have to borrow from that 3. So that's what I was talking about earlier. Excuse me, my throat's dry. That's what I was talking about earlier when I said it goes by tens. Since this is a smaller number, I have to take 10 away from this 3, which brings it down to a 2. Because I'm not really taking a full 10. I'm taking the 1, 2, 3, 4, 5, 6, 7, 8, and 9.